Hello everyone, welcome to Form 4 Additional Mathematics. This time we are going to look at Chapter 10, Index Numbers. So in this video, we're going to look at 10.1 index numbers, defining and describing index number. We're going to define index number, and then we're going to learn to describe index number calculated from a given situation. So before that, what is an index number? Before we look at the definition, we try to look at the two situations here. The first situation is I bought this laptop for 2,000, and then there's another one which said I bought this same laptop for 1,800 last year. So over 1 year, the price of the laptop has increases from 1,800 to 2,000. This is the first situation. Then the second situation. The numbers of students in this school is 500 this year. There are 500 students. And the numbers of students in this school is 550 last year. So meaning that last year 550 decreases to 500 this year. There is a decrease in the numbers. So a general idea for index number is that we can use index number to show the increase or decrease of a value. And this value can be price, it can be the number of students, and etc. But what actually is an index number, and how are we going to calculate this index number? Before we go into that, we try to look at the definition. Index number is a statistical measure to measure the change of a variable of a particular year as compared to another year. So we use index number as a measure of comparison for a variable. Then the variable here, it can be a price, it can be a value of currency, it can be a quantity, now as compared to another year, which we call as the base year. So of course, with this definition here, it's still unclear what is an index number. So don't worry, it is clearer after you look at the formula and the examples later. Okay, so we go to the formula. We look for an index number here. I represents an index. It can be a price index, etc. And Q1 here represents the price or the quantity at a particular year, divided by Q0, which is the price or quantity at the base year, which is the year that we want to compare to, multiplied by 100. So until now, we've looked at the definition and the formula, but it's pretty sure you're still very blur. So we go straight to the examples. Example number 1. The number of students of a school increased from 500 in the year 2016 to 800 students in the year 2017. So 500 increased to 800 from 2016 to 2017. Calculate the index number to show the change in the students' population in the year 2017 based on the year 2016. So 2016 is the base year. So whenever the question asks you to calculate the index number, you use this formula, where Q1 here refers to the price or quantity at a particular year. So since we want to find a change in the year 2017 based on 2016, so this Q1 refers to the quantity in the year 2017, which is 800. That's why it's 800 here. So based on the year 2016 means Q0 here is the quantity at the base year at the year 2016, which is 500. So we take 800, divide by 500 times 100, you get 160. So this number here, 160, is the index number, which shows the comparison of the number of students in the year 2017 based on the year 2016. But maybe you're still blurred. So what does 160 means? What does this implies? So I pause this question here. We are going to come back to these questions after we look at example 2. Example 2. The number of students of a school in the year 2016 is 500. And the number of students in the year 2017 is also 500. This is similar to example 1, but the number of students is 500 in the year 2016 and 500 in the year 2017 is still the same. Calculate the index number to show the change in the student population in the year 2017. This is the same as example 1, so we use the formula. So Q1 is the number of students in the year 2017. Q0 is the number of students, quantity here, the number of students at the base year, which is in the year 2016. So Q1 in the year 2016 is 500 students. Q0 2017, 500. So it's 500 over 500 times 100, which is equals to 100. So what information can we get from this index number, which is 100 here? You can see that when there is no change in the number of students, 500 and 500, no increase, no decrease, the I that you get will always be 100. Will always be 100. So, based on this example here, when there is no change in the numbers, in this case is the number of students, the I will always be 100. And based on example 1, when they are increased, this is example 1, we back to example 1 here, from 500 increase to 800. So when there is an increase in the number of students, we get these values, right? The I 160 is more than 100. So when the numbers increase, or the values or the quantities increase, the index number that you calculated will be more than 100. So in this case, in our example 1, the value that we get is 160, right? So 160 means that the number of students increase because 160 is more than 100. Increased by how much? Okay, so if we take 160 minus 100, because since 100 means there is no change, so 160 minus 100, this 60 here means the increase of number of students is 60%. So the 60 here give us the information that the values or the numbers increase by 60%. So for example, now, if in a given situation you calculate, when you calculate, you get the index is 120. This is the index number you get. So what conclusion can you make? You know that since 120 is more than 100, number increase compared to the base year. Increased by how much? Increased by 20% compared to the base year. This happens when the values or the numbers increase compared to the base year. But what will happen to this value? What will happen to the index number if the price or the quantity of value decreases? What will happen to this value? This brings us to example 3. A pencil costs 50 cents in the year 2014 and 40 cents in the year 2015. So calculate the price index for a pencil the year 2015 using the year 2014 as the base. This is the year that we are looking for the price index. So you can see that from 50 cents, it decreased to 40 cents, right? So the values or the price decreases now for this example 3. Okay, so first we try to find the price index, okay, using the same formula. So 2015, the price is 40 cents. 2014, the base year, the price is 50 cents. Okay, you can use 40 cents and 50 cents here, or you can change it to RM. It doesn't matter. The answer will be the same. So you get I equals to 80. So the price index that you get here now is 80. This is also an index number, okay, which we call price index because it is related to the price of an object. So what information can we get from the values of 80 here? Okay, so you can see that when there is a decrease in the numbers, from 50 cents to 40 cents, when the values decreases, the index number will be less than 100 because 100 means there is no change to the numbers value of quantity. So if it decreases, it will be less than 100. So in our example 3, 80 is less than 100. So we know that the values decreases. Decrease by how much? So we take 100 minus 80, which is 20 here. So it decreases by 20%. So from this 80 here, from this value here, we obtain the information that the price decreased by 20%. So as a conclusion, when the price or the numbers of a quantities increases compared to the base year, the index number will be more than 100. If there is no change to the net values, the index number will be 100. When it decreases, it will be less than 100. And from how many percent it increases or decreases. That is the use of an index number. So now we try more examples here. Example 4. A box of tissue costs 2 ringgit and 20 cents. and 3 ringgit 60 cents in the year 2009 and 2016 respectively. So it means in the year 2009 it costs 220. In the year 2016 it costs 360. Calculate the price index of a box of tissue in the year 2016 based on the year 2009. Okay, so the 2009 is the base year. Price index, when you want to calculate price index, you use this formula, where Q1 is the price in the year 2016, which is $3 and 60 cents. Q0 is the price in the year 2009, the base year, which is 2 ringgit 20 cents. Calculate this, you get 163.64. For index number, you can give two decimal places. What conclusion can we get from the price index here? So the conclusion is the price increases by 63.64%. Because you take this, you minus 100, okay? So it increases by 63.64%. We try one more example here. So this time, in the year 2009, the price of a clock is 15 ringgit. In the year 2011, it's 20 ringgit 25 cents. So calculate the price index for year 2011 based on the year 2009 for the price of a clock. So now for A, the base year is 2009. For question B, is 2009 based on the year 2011. The base is 2011. So the base year can be any year depending on the situation. Any year can be used as the base year. So for question A, okay, price index, we use the formula. 2011 is 20 ringgit 25 cents, so Q1 is 20 ringgit 25. Based on the year 2009 means Q0 is the price for the base year, which is 2009 15. Okay, so you get this, you calculate, you get 135. Now question B, we use the formula again. This time you just Q1 is 2009, the price in the year 2009, which is 15, and Q0 is the price in the year 2011, which is 20.25, and you get 74.04. So from this example, you know that base year can be any year. It does not have to be the previous year. A pen cost 1 ringgit in the year 2013. The price index of a pencil, this time the price index is given, is 125 in the year 2015, using the year 2013 as the base year. Okay, so this example is different than the previous example because the index is given. Calculate the cost of a pencil in the year 2015. Instead, you need to calculate the cost, not the index number. But since the price index is given, we use the formula for index number. I is the price index, which is 125. So this is 125. So now Q1 and Q0, you need to make sure which is the base. Okay, so 2013 is the base year, means Q0 is the price for 2013. Do we have the price for 2013? Yes, it's 1 ringgit. So Q0 is 1 ringgit. Q1 is the price of the pencil in the year 2015. It's the cost of the pencil in the year 2015, which is the value that we are going to calculate. So we fill in this 125, we fill in this 1 ringgit. You bring the 1 ringgit here, you bring the 100 here. Okay, you get this, you calculate, you get Q1 is 1 ringgit and 25 cents. Example 7. A box of chocolate costs 12 ringgit in the year 2016. Calculate the cost of a box of chocolate in the year 2017. Again, this time you need to calculate the cost, not the price index. Based on the year 2016, if the price increased 25% in 2017 compared to 2016. So from 2016, it is 12 ringgit. And when it comes to 2017, it increased 25%. So this actually tells us that the index of the cost of the box in the year 2017 based on 2016 is 125, because increased by 25% means 100 plus 25, so you get 125. So now we are going to use this to help us to find the cost of the box of the chocolate. So we use the formula. I is given 125 because Q1 is the cost of the box of chocolate in the year 2017, where Q0 is the cost of the chocolate in the year 2016 because it's compared to 2016. So Q0 is 12 ringgit. So you get 125 equals to this. You remove the values there to calculate Q1. You get Q1 equals to 15 ringgit. So the box of chocolate costs 15 ringgit in the year 2017. We go to the last question example, which is the hardest one. The price index of a pair of shoes in the year 2012 based on 2000 is 140. The price index given is 140. If we write the information here, we get this. Previously, you haven't seen me return the price index in this form. Because for this question, it involves different years. So usually I will write like this so that it's easier for us to identify the index. Okay, so this means that this is the price index in the year 2012. The stroke here means based on the year 2000, okay, is 140. This information comes from the first sentence. Then the price index decreases from 10% from 2012 to 2015. So means 2012 is the base year and 2015 is the current year. So when we want to find the price index, is I 2015 over 2012, and it decreases by 10%. Decrease by 10% means the price index of 100 minus 10 is 90. So I 2015 based on the year 2012 is 90. This is the second information from the second sentence. Now we want to find the price index of a pair of shoes in the year 2015 based on the year 2000. This is the index that we are looking for. So now you see it involves 2000, the year 2000, the year 2012, 2015. When you have questions similar to this, there are different ways of solving this question. So in my example here, I'm going to use a table to help me. Okay, this method here where I need to identify the year. You see we have 2012 and 2015 here. And then the base we have 2000 and 2012. So in my table, the first row here, I will list down the year from here, 2012, 2015. Okay, so since I only have two types, this is the same as this. So I have 2012 and 2015. Then we go to the base. We have 2000, 2012. Okay, 2000 is the same as this. So I have 2000 and 2012. So this column here is for the base year. Then we try to fill in the values of the price index. Okay, so for this slot here, we will find the price index for 2012 based on the year 2000. So from the information here, we already get this, which is 140. For this slot here, we are going to find the index for 2012 based on the year 2012. So you can see that it's from the same year. Of course, there is no change to the price because it's from the same year, 2012 and 2012, based on the same year, no change in the price. So the price index will be 100. For this slot here is the index for 2015 based on the year 2000. So 2015 based on the year 2000 is the value that we're looking for. So we leave it blank. We leave it here. We go to the last slot. We have the price index for 2015 over 2012, which is 90. Here, 90. For this example, all the information of the price index is given. For some questions, you have to calculate the price index by yourself. Right? So for this example here, all the information is given. So we have this. And now, using this table, we can find this value. This is a shortcut method where 140 divided by 100 equals to this value divided by 90. Okay, this divided by 100 equals to this divided by 90. Yeah, so 140 divided by 100 equals to this divided by 90. So if you can build this table and find all the values inside here, you can take this divided by this equals to this divided by this. Then if you want to find this index number, you just move the 90 to the left hand side, you get this, and you have the answer. You calculate this, you get the answer, which is 126. Means The price index for 2015 based on the year 2000 is 126. Just a note here, this is just one of the different available methods that we can use to solve this problem. So this method is useful when it involves base of different years. So right now you may pause this video and try this method on textbook example 3, page 275. And lastly, I'll see you in the next video. Thank you everyone.